Alrighty, here we go again. This is lesson 8.6. Hopefully I don't have to let my dog out or anything during this lesson. I'm sitting in my living room. It's almost 10 o'clock on Saturday night. Not too exciting, but we're getting things done. So 8.6, how much does a loan cost? This is applications of what you've learned so far this chapter. So by the end of this section, you should be able to determine the total payment made and installments for car loans, mortgage payments, and other kinds of loans and long-term periodic payments. So let's get started. If I can get my cursor back. Okay, let's get terms and things down. In a loan, the principal is the amount you borrow. To pay back the loan, you have to pay back both the principal, or the amount you borrowed, and some interest. That's how the bank will lend you money, is they make money when you have to pay it back. The interest rate is the percent of the borrowed money that the borrower is charged. The term of the loan is the length of time the individual has to pay back the entire loan. So let's just start with an easy loan. Let's say you buy, I don't know, an okay used car. So you're going to borrow $7,000. R is the interest rate, and it's equal to 1 plus the annual percentage divided by 12. M is your monthly payment. So we're going to start at the time you borrow or the money, $7,000. That's kind of our time zero. Notice we're using 0 as our subscript here. So you borrow $7,000. Then a month later, so at the end of 1 month of owning your new used car, the $7,000 is assessed interest, and then you make a monthly payment. So they subtract that amount of money from what you owe. Then at the end of another month, you have the balance from last month represented here. They take that balance, charge interest on that for a month, subtract that monthly payment. If you simplify it out by distributing the R, then you have, okay, having a little pen trouble. Distribute the R, then you have 7,000 R squared minus MR minus M. The third month is like before. So you take what was the expression for the second month, you multiply it times R because it's interest on what you still owe. Then you make a payment. Notice they charge you interest and then they make your payment, but that's because the interest is for the month that has passed. And then they subtract the payment. So distributing the R, 7,000 R cubed minus MR squared minus MR minus M. Notice it's the third month. The biggest exponent is 3. I think you see a pattern. So here we go. So if your loan is for 3 years, that's 3 years, 12 months in a year. 3 times 12 is 36 payments. In order to have a zero balance, you're going to start with $7,000. You will have had 36 months to pay it off, minus M times, now these are all the M's. So the M has been factored out, and you have R to the 35, R to the 34, R, and all the way down to R to the first, and then R to the 0 or 1. Let me go back here. And you see again that it was 7,000 R to the third, and then all the MR. So here's where you're factoring the M's from. Okay, so there's the M that's been factored out. Here's the rest of this. Well, if you'll notice, this is a geometric sequence. Well, series, now that you're summing them up. The first term is 1. After the first term is 1. Then times R, then times R, then times R, all the way up to R to the 35th. And there's R to the 36th. So we replace this with our formula for a geometric series. The first term is 1, so you can distribute your 1 or whatever you want to say. You don't have to write it here. And now you have MR to the 30, I believe that should be 35th. Oh, first term, second term, third term. That's why it's 36th. 10 o'clock at night. All right. So we have this. Whoa, get back here. we have this formula. I've got my tablet sitting on my computer, so sometimes it advances. Okay, now you've got this formula here. You want to solve for the monthly payment. So we're going to add this to both sides. That's what we've done here. And then we're going to divide both sides by this because it's m times this. Well, instead of dividing by a fraction, we're going to multiply by its reciprocal. You see the reciprocal over here. So the monthly payment equals the amount borrowed times r to the 36th times the quantity 1 minus r over 1 minus r to the 36th. So that's how we derive the formula for finding the monthly payment. So if you find a car you want to buy and you figure this out, a monthly payment you could pay, then you can calculate in what interest rate you need, how much car you can buy to be able to have the monthly payment that you want to. Okay, let's see what's next. Oh, I think that's the only thing. So let's go back here and let's calculate this. Let's say that your interest rate is a nice 4.5%. That'd be pretty hard to get for you, but maybe, maybe it'll work out. So we're going to take the rate here and call it 1, we'll put it in brackets. Pretty ugly bracket. 1 plus, let's say 4.6%. 0.046 divided by 12. It takes a yearly rate, divides it by 12 because it's over 12 months. That's your monthly rate. Adds 1 to it because you've already borrowed $7,000 and they're adding on to that. So that's what you'd put in for this R, for this R, and for this R. And then you'd calculate what your monthly payment would be for that amount of money borrowed. Looks like the rest are just additional examples, and they're from an older edition of the book. So you can earn 0.5% interest. You can work this through. I'll try to post some answers for this maybe. Oh, of course, here it is. So it looks like we had 0.5% interest, $100. You can see this worked out. So for any monthly payment, this is the formula they've got in your book. You can also put this in a spreadsheet. That's a very common thing to do. If you look in your book on page 537 to 538 and read that, and then an annuity table is a very common thing. When I first got my first house, they gave me a spreadsheet with all of this, maybe 8 columns across, what month it was and how much would have to be paid and how much the interest would be. And then you'll notice when you make these payments that the early part of a loan, most of your payment goes to pay off the interest that's accumulating on the money you borrowed. Then as you pay down the loan, more of the money goes toward your principal, and because there is less interest, because you've paid down more interest. So you owe less money. You've paid down more principal. So you owe less money. Because you owe less money, there's less interest on it. So when you make the same amount of payment, it pays off a smaller amount of interest but a larger amount of the principal. My advice on any time you get a loan is to make sure you can pay it off early. And then as you make payments, always find some extra money, even if it's an extra $10, $20 a month, to pay against the principal. And that will cause your principal to go down faster, therefore your interest charge to go down faster. Therefore, you pay it off faster and you pay way less in interest. Ask your parents if they have an annuity table, maybe from when they bought their house or such, and they can show you how much you actually end up paying for a house once you've paid off the interest. Is crazy following the loan. Okay, here's another version of the formula. I guess the previous one was the former edition of the book. And then this is one in your book now. The periodic payment required to pay back a loan of P dollars and N equal installments. So you're paying the same amount each month at a rate of R per installment is this. Again, R equals 1 plus your annual percentage divided by 12. If you would like to earn some extension points, go back to the previous formula and derive it to reach this formula. So here's the formula. Imagine you're buying a used car and have to borrow $6,000, but you want to spread the payments over 5 years. That's 60 months rather than 3 years. You go online and find that the monthly payment would be $124.55. Verify that the $124.55 is the correct monthly payment. So we're going to write out our formula. We borrow $6,000. 1 plus, do we have an interest rate? Looks like we'll experiment with an 8% interest rate. So 0.08 over 12. There are 60 payments, then times the rate again, which is, in this case we're putting the rate here, so 0.08 times 12, and then 1 plus 0.08 times 12 and minus 1. So I typed this, as you can see I typed in the calculator. You can't see the complete equation, and I got 121.66 would be your payments. Practice putting this in your calculator. As you do, you're going to have to really watch your parentheses. You're going to need to put parentheses around your numerator and around your denominator. And then, of course, you'll need the inside parentheses here. Depending on what operating system you work on your calculator, you may need to put parentheses here or here. Try the minimum and then see what you need. Do it until you can get it to match the 121.66. If you heard my phone go off, that was the storm warning again. We keep hearing about it. We'll see if it happens. Okay, example 2. Suppose you get a car loan to borrow a $15,000 car over 3 years at an annual interest rate of 10%. What's the corresponding monthly interest rate? How long would it take to pay off the loan if you paid $800 per month? Would you be able to pay off the loan in 3 years if you paid $400 per month? You have to calculate the variables. You have to say how much, maybe you limit how much you can borrow according to how much you can afford to pay each month and what interest rate you get. Maybe you can only get so many, you can only take the loan if you get a certain interest rate. You have to decide what are your set things that you cannot change, like how much you can afford to pay a month and such, and then figure backwards into how much you can afford to borrow. Okay. So $15,000 over 3 years. Let me roll this up a little bit. Advanced one. And roll it up. Let's try this again. Okay. So $15,000. 1 plus the interest rate is 10%. No decimal point there. That's 60 payments, and then again times 0.1 over 12. Whole thing divided by 1 plus 0.10 over 12. 60 here minus 1. If you're typing this in your calculator, which would probably be the smartest thing to do, make sure you have at least this. What is the corresponding monthly interest? That would be the 0.10 divided by 12. How long would it take to pay off the loan if you paid $800 per month? So here you're going to make your monthly payment $800. You're going to set your amount borrowed is your $15,000. And then your 1 plus 0.10 divided by 12. N is what you don't know. 0.10, 12. And then 1 plus 0.10 divided by 12 to the nth power minus 1. Now on this one, we haven't yet studied logs this year. If you want to use logs and properties of logarithms from previous year, you can. At this point, with this formula, I would recommend simplifying and then typing this in y1, put this equation in y2 as we did earlier, graph them, and see where they cross. Then the next question is, would you be able to pay off the loan in 3 years if you paid $400 per month? And let's go down below. So you want to be able to pay $400 per month. So now you have black ink. $400 is your monthly payment. The question is, would that work if you still borrow $15,000, one, same rate, 3 years, 3 times 12, 36. Oh, forgot that extra R. And I'm copying the formula from above. This will be 36 again, minus 1. So if you graph this in y1, you probably already have this in y2. If they cross, you have a solution. If they don't cross, you don't have a solution. I'm going to leave that for you. The next time I see you, we'll talk about it. Oh, I guess I gave it away at the 800. There's your answer for the 800. I'm not going to answer the 400. Well, not right now. Okay, 5 years after you graduate from college, you decide to buy a house. You buy a house for $250,000 at an annual rate of 5.85. This is very reasonable information to be paid back in monthly installments over 20 years. Often your first house loan is 30 years. What will your monthly payments be? So we're going to put $250,000. It's crazy when you actually think about this. $250,000 times 1 plus 0.0585, move the decimal 2 places, over 12. 20 years, 20 times 12 is 240 payments. 0.0585 over 12. Put that whole thing, which means type in your calculator, parentheses around the numerator, parentheses around the denominator. 240 minus 1. There you go. Once you get that monthly payment, the next thing to do is to see how much you actually pay over 20 years for your car. Let me go make sure I didn't have that down here. No. So let's find that. Once you find that monthly payment, we'll call it M. Take your monthly payment times the 240 payments you make. Then subtract from that the original amount you borrowed. What is that? That is interest paid. You will be shocked at what you get when you see this. That's how much extra you've paid to be able to pay for your house over an amount of time. So that was a quick lesson. How much does a loan cost? You figured out how to make monthly payments, how to calculate the whole installment thing, how much interest you have to pay. and all such. Makes you much wiser in money. Moral of the story, don't borrow money unless you have to. Alright, quick lesson. I'll do 8.6 on a separate video.